Okay, let's do the same thing now with the quotient rule. So before you start, I would like you to remind yourself of the quotient rule. If I have two functions and I'm looking at the quotient of the two functions and I want to take the derivative, then could you please write out how you would do quotient rule? Okay, and order matters, right? So we've got gf prime minus fg prime. Okay, I bet you're going to have to flip back over the page because you're going to need to know two derivatives. The derivative of secant x, and you're going to need to know the derivative of tan x. So look them up on your chart, write them down, and then let's do the question. Okay, what's the derivative of secant? What is it? Secant x, tan x. What's the derivative of tangent? Secant squared x. Okay. Okay, so quotient rule, we need to find the derivative of this quotient of functions. So I'm going to have my denominator 1 plus tan x all squared. So quotient rule, low 1 plus tan x times the derivative of secant, which is secant x tan x, minus the top, which is secant x, times the derivative of the bottom. What's the derivative of 1 plus tangent? Well, the derivative of 1 is 0, and the derivative of tangent is secant squared. Okay, so one more time. We're looking at g, 1 plus tan x on the top, times the derivative of the top. The derivative of secant is secant tan, minus the top, secant, times the derivative of the bottom, which is secant squared, all over the denominator squared. You want to put in a plus 1 here. Why? When you're taking, we got, how did we get the secant squared? We got it by taking the derivative of 1 plus tan, and the derivative of 1 is 0. Okay, so that's a really awkward question or answer, so let's simplify. Do you see that you've got a GCF on the top? Secant. So let's pull out the secant. We've got secant x, and it will end up being 1 plus tan x times tan x minus, we pulled out the secant, we're left with a secant squared, all over 1 plus tan x all squared. Okay, so this tan distributes to both of those terms. You're going to get tangent plus tangent squared minus secant squared. Do we all see that? Okay. So I've got secant x bracket tan x plus tan squared x minus secant squared x all over bracket 1 plus tan x all squared. Do you see any Pythagoras identities? As in, what is tan squared minus secant squared? Yeah. Okay, so this is secant x bracket tan x. Oh, actually, it's not 1, is it? It's negative 1. Minus 1 all over 1 plus tan x all squared. Did I answer the question, by the way? Let's go back and look. What was our question? Differentiate this. Okay, we did. For what values of x does the graph of this function have a horizontal tangent? How would I know if the tangent is horizontal? The slope of the tangent line, f prime, would equal 0. So where is this equal to 0? Well, if the numerator is 0, so m equals 0 if either secant x is equal to 0 or tan x is equal to 1. Is secant ever 0? It's the reciprocal of cos. Right, remember what the secant graph looks like? Cos looks like this. When you're taking a reciprocal, every 0 becomes a vertical asymptote. Every 1 and negative 1 becomes an invariant point. This is what secant graph looks like. Do you ever get a 1 out of secant? No. So this can't happen. The only way we're going to get this to be 0 is if tangent is equal to 1. What angles have a tangent of 1? Pi by 4, right? Because it comes from your special triangle, 1, 1, root 2, pi by 4, pi by 4, pi by 2. Okay, so x equals pi by 4, and then we're going to say plus n pi, where n is an integer. Can anybody see an easier way? So f at x is equal to secant x over 1 plus tan x. Does anyone see an easier way to take that derivative? Using trig identities. What's another way for defining secant? 1 over cos. How do you define tangent? Sine over cos. So really, that's a fraction of a fraction kind of a question. What's the denominator on the top? And the denominator on the bottom? Cos. So what would happen if before we even started, we just did this, multiplied by 1? Wouldn't that simplify our question? Because on the top, what would I get? Secant times cos. A function times its reciprocal is 1. Distribute to both terms, you'd get cos x plus, what's tangent times cos? Sine. Okay, that might be an easier thing to take the derivative of. You still need a quotient rule. What would f prime look like now? Well, we would have denominator squared, cos x plus sine x, all squared. And how does this product rule work? Well, it's the bottom times the derivative of the top. What's the derivative of the top? 0. Minus the top times the derivative of the bottom. The derivative of cos, negative sine, plus the derivative of sine, which is cos. So I would get, distributing that negative through, sine x minus cos x over cos x plus sine x, all squared. And I'm going to tell you that these two are the same question, are the same answer. So for tomorrow, I would like you